Okay, welcome everybody. Let's get this started. Cool. Woo! Energy, right? Ah! More coffee. Where's Michelangelo? All right, cool. Well, as you guys get settled, I'll start talking about this. So, first of all, it's really cool to be here in Dresden. As a half German, half Brazilian, it's always good to come home, even though I can't speak the language. So please don't try and talk to me in German. Yeah, I will probably insult you in some way, but you know, it's cool. So I really want to talk to you about application metrics, and I chose Prometheus as one of the tools to show us a little bit about how to do metrics on a practical level. So, I mean, this is a talk that has Prometheus, so we also need to think a bit about how is it that you do metrics, right? And I could not get through a talk that actually mentions Prometheus without asking if you do metrics the way the scientists did in Prometheus. Right? Let's just poke at the alien thing and see if it does anything. Yeah, I sure hope that's not how you do metrics. So I really want to get into a bit more of real science into how we can do this. First of all, my name is Raphael Dohms. I work at a company called Usabilla, where I'm one of the lead engineers. We're hiring. That's the usual thing that everyone needs to mention. So if you're looking to move to Amsterdam and you want to work with awesome people, do check us out. Now, usually I would not spend too much time talking about what we do. Usabilla is a feedback company. But today, since we want to talk about metrics, it's actually a lot easier to understand thinking about metrics if you have a concrete example. So, Usabilla is a feedback company. Essentially, we allow you to receive feedback from your customers, right? So is your website working? Is this button not working? Maybe something is not good. And Usabilla started off, 5 years ago, collecting feedback only for websites. So it's this feedback button that we used to support. And as it grew along the way, as any startup does, it needed to really get into market really quick. It needed to expand. It needed to get new features and new products out there. So now we support web, mobile, email, all kinds of different feedback channels. And of course, each of those was implemented as a completely different code base that stores the data in completely different places. Because startups are really good at making choices, right? So this was 5 years ago, and it's good. It got Usabilla in the market. It's one of the leading tools for feedback. But you can imagine that in a market that changes constantly, like we do, it's probably not the best thing. So we took a look at what was going on within the market, what was the requests coming in for features, and we actually realized the market shifted. We no longer wanted to look at feedback from specific places. We actually want to look at feedback as one big thing, right? We want to be able to look across all of our websites and apps, because now you're no longer an app or no longer a website, right? You have a website, you have an app presence, you have email mailings, you have your knowledge pages. You want to look at all of that across each other. So we realized that the market changed. We looked at our system and said, okay, we need to make the system work so we can look at data as if it's one data. Turns out that was not quite possible. We looked at the code looked at us, and we're like, yeah, this is not going to work, right? So we kicked off a new project, and essentially what we started doing is we started rewriting the engine behind Usabilla, right? The real gut of the entire system. So we call this the Unified Pipeline Project, because we like long names that are not too meaningful. But the idea is, this is the center of everything. This is where a feedback item comes in, where we process that data, consolidate it, make sense of it, and then finally give out the metrics and give you the understanding of what is going on with your clients. Now, this is really cool. We started this entire new architecture using Kafka as a messaging bus. We built the entire system with microsystems, and even more than that, we built them with autonomous microsystems, which means instead of going to get the data from an API, the data comes to the microservices, right? So we don't create cascading failures. We did all of this basing what these microservices are based on a DDD architecture, finding our bounded context, isolating them, and making sure that we had integrity within these layers. Now, I'm not doing this to pitch for you to come work for Usabilla, although it is pretty cool. But the idea is this is a solid application. And with this, I want to show you a bit of how we thought about our metrics and what metrics actually mean to us and how they can really help you architect your system and build more. So metrics are nothing but insights into the current state of our application. Right? Metrics are how we look at the application and we figure out, is this application healthy? Is this application not healthy? Now, you can also think about metrics in terms of performance. Well, is this the best code I can write to do things in the speed that I want? Those performance metrics are also part of this, but if you're looking for those, then there's a talk in the next track, which is really about the performance of code. But metrics are not just that. Understanding if your application is healthy or not is not just a matter of, is it responding? Is it fast? Is it slow? It's also a matter of, is it delivering the value to your users that you're expecting to deliver, right? So it's also important to have metrics if you're doing things like canary deploys. Well, you know, you want to check if the application is healthy, then you start rolling out the new version, you know, blue and green deploys, things like that. So metrics really help you a lot in various different areas of hosting an application. Metrics can also tell you what's wrong with your application. But they can also tell you what's right with your application. They can tell you how much feedback is coming in, how many people are actually interacting with the system. Are my databases healthy? Is something taking too long to go through our pipeline, right? But they can also help you and figure out what will soon be wrong with the application. You can start seeing trends, like if you start seeing a queue backing up, if you start seeing a different system not responding, it could be a symptom that you can get ahead of and try and figure out what's wrong. Maybe one of your workers is down. Maybe you don't have enough workers and you need to scale that up. But metrics, from a day-to-day basis of a developer coding, they also help you figure out where to start looking if you have a problem, or even if you don't have a problem yet. By looking at the metrics, you can see, well, you know, this is the performance I want, this is the performance I'm getting, where should I start looking? Is this all the way back down here in my endpoint? Is it all the way back there in my queue system? Where are these problems coming from? Cool, so how many of you do metrics on a day-to-day basis? All right. Probably using systems like Influx, Graphite, Prometheus maybe. Anyone using Prometheus already? Okay, cool. So please keep me honest if I mistake something, because you know, it's been known to happen. Cool, so the ideas behind application metrics that I want to share today are not just the metrics, but there's a whole ecosystem around this. And there's a book published by O'Reilly Media about site reliability engineering, right? So this is based on Google's internal approach to reliability and how they keep their services up and how they measure that. And it defines 3 interesting areas to work with: SLIs, SLOs, and SLAs. How many of you are familiar with SLAs? Right, that's usually the first one we always hear. Have you ever heard about SLOs and SLIs? One person. Cool. You have a lot to learn today. Great. All right. It's a good thing I'm here. So SLIs are essentially what we would consider metrics. SLIs are the service level indicators. They're the things that indicate what that thing is, right? Or how is it going. The SLOs, on the other hand, are objectives, service level objectives. They'll tell you what you're aiming for. And then finally, SLAs are service level agreements. So let's dive a little bit deeper into that. So, SLI, essentially a metric, essentially is that number, that quantitative value that you can get from something. So you can say, hey, my application responded in 150 milliseconds. That's a metric. That's an indicator that you have. You know that the response time is something that you can measure quantitatively with a number. So you need to start there, right? You cannot make decisions, you cannot define objectives for yourself if you don't have the metric to start it off. Once you have SLIs, you then look at SLOs. SLOs are objectives, is where you want to aim, right? So I expect my response time to be less than 180 milliseconds or 200 milliseconds. That's an SLO, it's an objective. Now objectives seem like, oh well, it's just something we're aiming for, but they actually carry a lot more value. So as you define the SLO, and it's very important to define an SLO together with your business department, together with your business in general, to understand what does that indicator mean to you. It can also help you make architectural decisions, right? So I'll give you an example that ties back to the pipeline. The first part of the pipeline, the part that receives feedback, is a highly scalable system that essentially just needs to take the data and stick it in a Kafka queue. it needs to be fast, right? We're receiving feedback from every single website that is one of our customers on the web, so it needs to really respond to high traffic. So we want to make it as simple as possible, and we want that delivery to be as quick as possible. So we defined that our SLO for the response time of this API was 150 milliseconds, and I'll get into how we got to this number later on. We decided to move away from big frameworks like Symfony and Zen Framework. We didn't need that much. Again, this endpoint literally takes the data and puts it into Kafka. So what we did is we rolled out a solution on top of Zen Expressive with a thin layer of CQRS facilitation called Chimera PHP. You can check it out. It's one of Luis Kobuchi's projects. And it was really simple, right? We really stripped down to the bare bones of what we needed to do in terms of a request. Now, it turns out that the very first time we ran this and we checked it out and we put it under stress, it was responding with a 99 percentile, actually 95th percentile of 5 milliseconds. So in general, the application was always responding in less than 5 milliseconds. Okay, if our SLO was 150 milliseconds, I think we're pretty much have achieved that, right? Math doesn't fail me. So what we decided is, instead of spending more time trying to optimize and remove layers and remove frameworks and getting these things out of our way, we could actually spend more time in other areas. But that's the thing about SLOs, right? They're supposed to help you make these decisions. Do I need to make this better? Do I need to make this different? Do I need to change the architecture? Do I need to handle this in a different way? If you're already achieving the SLO and you're already delivering the value that you want, then maybe you can spend time in other places where you can deliver more user value than you could in here. Cool. And then finally we have SLAs. And SLAs is where we attach consequences to our failures, right? So you take an SLO, if the SLO is to be below 150 milliseconds, and all of a sudden we're above that, what does that mean? Does it mean I'm going to give the client their money back? Does it mean nothing? Does anyone not care? Maybe you shouldn't even have the SLO. But the SLA is where you attach that consequence. You say, hey, this is my commitment that I want to keep this here, and if I don't, this is what the effect is going to be, right? And it's definitely something that usually doesn't come from the development department. It's usually something that comes from business along with your legal departments and you know, things like that. Cool. So let's start by first figuring out how we begin this. So to begin the whole thing, you need to start measuring, right? Plenty of you already said you're using metrics, so let's talk a little bit about what is it that we're supposed to be measuring. A while ago, I read an article from Etsy. Everyone know Etsy? So Etsy is this big American website for crafts and releasing your own web shop for like small crafty things that you do. And it's absolutely huge. It's huge. It's like really huge. It's where the Rasmus, the creator of PHP, works. And they do a lot of stuff there. So they released this article about how they look at measuring, how they look at metrics. And essentially what they said is, if it moves, we track it. Now if you think about the size of Etsy, that's a lot of tracking. That's a lot of data. Okay, if it moves, we track it. Okay, that sounds like a lot of things. Let's break that down a little bit. So if we look at metrics in general, we're talking about two different situations. We're talking about telemetry, and we're talking about statistical data. So telemetry data is all about measuring the moment, understanding what's going on with the application now, whereas statistical is more about identifying trends and looking back in time. So if you're a fan of Formula 1, you've probably heard of telemetry, right? They're able to measure right there on the car with a specific sensor everything that's going on, from the temperature of the tire to the grip of the tire to everything within the engine, how it's working. Now they do this with such precision, they have such a complete model of what the car looks like that they're actually able to tell the driver, yeah, if you turn the wheel a little bit more in curve number 5, you will gain so many milliseconds in your lap. So much so that it was forbidden by the FIA to be giving these tips out, because at the moment you wouldn't need a driver anymore, you just need a robot to execute those actions. But that's the same thing for your application, right? You want to know exactly what's going on. How is my application responding? How many things are coming in? How many people are we serving? Are they going through my pipeline quickly? Are they getting hung up somewhere? Am I giving the users the data that they expect, or am I just delivering empty payloads? All of these things are things that you want to know. You want to be able to look at your website and know exactly what you need to do. Maybe we need more servers. Maybe we need a higher queue. We need more workers. You need to be able to tell these things. And that's what telemetry is all about, is looking at that current moment and giving you a sign of what's wrong. Right? This is the moment where you look up on your dashboard and everything is red and you go, yeah, okay. No, actually, you need to freak out, right? You need to look and say, okay, something is wrong. Let's go figure it out. Let's go find this. On the other hand, you have statistical data. And statistical data is all about looking back to these trends. Same thing, keeping the Formula One trend is how you look back at championships. Like, oh, 2 years ago, this is the people who won. Oh, it turns out that this guy never won before. It turns out that these people are always in the top 10. So you start understanding trends from your users. Oh, well, I see that every time we hit a Friday and there's a football game, we get this peak of users and the website is not responding well, right? Or, you know, for whatever reason. You need to understand these trends. And it's like being able to go back and, like, for example, when was the last time a Brazilian actually won championship? And it turns out it was 1991, which is way too long ago. I really do miss Ayrton Senna. Any Formula One fans? Cool. Guessing you all cheering for Vettel? No? Hamilton? Yeah, okay, cool. All right, Formula One, not the most, yeah. Cool, but that sets the point of what's the difference between telemetry and statistical data. So when we looked back at the pipeline and we looked at the data we had and tried to understand, we actually found a couple of examples of this. So on the one hand, for telemetry, we wanted to know exactly how long the public endpoint was taking to respond, because that's the feedback that we have directly with our clients. This is the moment where we told them, yeah, okay, we just got your feedback, you're good. So we need to know if that's going well. The moment that starts dipping, then people start feeling, well, maybe my feedback didn't arrive. Maybe I haven't given my feedback correctly, right? Whereas statistical data, we want to know what channels are giving us more data, for example. So we do a count of the feedback items coming in and understand, well, the web is giving us 80% of our data, mobile is only giving us 10%, and that helps us make business decisions. Well, this product is selling way better than that product, for example, right? So understanding how these things work is really important for the business. But then we go back to what Etsy said. He said, okay, we need to, you know, if it moves, we track it. All right, so then, you know, you can track things like, you know, system throughput and the request latency, is my system available, the error rates, but then you remember, oh, you can also do that for the CPU, for PHP, for your memory, you know, you can find peak frequencies, you can find, you know, your node stuff. Whew. Then, if that wasn't enough, you can start measuring, you know, your measuring tools to see if they're actually measuring and still receiving data, because you could be publishing data and it's, you know, falling on blind ears. It's a lot of data. It's a lot of metrics, right? So working in the feedback industry has taught me one thing about humans. And that is, if you overload them with information, they have no idea what to do with it, right? If I stood here and I simply read out the list of everything that you can do with metrics, well, half of you will be asleep, the other half will be trying to pay attention, but still wouldn't remember anything tomorrow, right? So humans are not really good at being blasted with information, except if it's Twitter. Apparently Twitter we pay attention to, I don't know why, right? But the same thing with metrics. If you just measure everything, and you just have all this information there, and you try to care about all of them, you're actually caring about none of them, right? So you need to reduce that scope a little bit. Now, if we think about the scope of all the metrics we have in an application, that's cool. Metrics are one thing. There are things you can measure and there are things you're actively measuring. Doesn't mean you need to care about all of them, right? So within that scope of everything you can measure, we have a subset, which are actually our SLIs. So not every metric that you measure is going to be an SLI. Otherwise, again, you'll be overwhelmed by all these numbers. So you need to get good at picking the right SLIs. Right? How, of all this data that I can measure, which ones should I be measuring? So the first thing to understand is that the SLIs actually change, the important ones, depend on who's watching. Like if you're a developer looking at it, then you might care about some values. If you're a product owner, you might care about different values. If you're someone from ops, you might be looking, well, actually I care about the CPU, I don't care about the application. Right? It really depends on what role you're playing within the organization. So it's very important to know that. But it also changes depending on the nature of the system you're looking at. So for example, if you have a user-facing system, things like your latency and your availability are very important. Right? You want to make sure that your application is always up when users try to see it. You want to make sure that they are always quick when users are trying to load it. And you care about the throughput of it. Can it actually handle all these things? All these people coming into my website. Whereas if you're talking about a storage system, you care a lot more, for example, about the durability of your data. I mean, if you have a database that you put data in and it doesn't store the data, it's kind of not a database, right? You want something more. So you care about, is that data being persisted? How quickly am I serving it out again? Do I always deliver the right data? So different metrics, different system. Big data systems, right? Big data systems is where you are sending insane amounts of data and you need to be able to handle all of that. So you care a lot about the throughput, about your availability to consume all that, and you care about how long it takes from data to go from A to B. So depending on your system, you really need to understand what is important. Where is it that you deliver the value, and how does that value get delivered to the user? So going back to the example of the pipeline, we looked a little bit into the nature of it. As it turns out, we have a system that's mixed, right? It's a user-facing system, as we have that endpoint that receives the feedback items, but we also have a big data system because we are receiving a lot of data. So we needed to make SLIs according to that. So we looked at them and we figured out these were a few of the ones we cared about. The response time of the endpoint. This is how quickly the user gets a response saying, yep, we got your feedback, we're good. The turnaround time. So from the moment that someone gives you feedback to the moment that our customers can actually see it in the back end, that's really important, right? Because if you come to our website and you give me feedback and I can only show you that information tomorrow, it might be too late for you to act on it. The quicker we can get that information to you, the better. Also things like the processing time for each of the steps. So once you get into the pipeline, we do a series of processing on the feedback item, right? We chop it up, we simplify it, we reorganize it, we restructure, a bunch of stuff. We also have a bunch of legacy transformations because legacy is always part of ongoing life. But we want to know how each of these steps are going, because depending on how that's going, we need to invest more time into this step or that step. And then finally, we needed to understand, okay, just how much feedback is coming in, how many requests per minute do we have, how many feedback items are coming in from each channel. So that's what the development department judged was interesting for them. That's what we looked at and said, you know what, these are the things we need to keep an eye on. If any of these things start changing, we need to do something. But then we also talked to our ops engineers, and we went to them and, well, the application is going live, what do you care about? And they showed us an entire different set of metrics that were of value to them. Things like, PHP FPM metrics, the memory, the CPU, how much data, how much storage do we have on the server? How big is our cluster? How many machines do we need to run this monster? And then, can we do it better? Is Kafka actually sending messages, or is Kafka just saying, yeah, it's good, I got your message, but it's not going anywhere? Right? So they cared about a completely different set of metrics than we did. So their SLIs are different than ours, which means also their SLOs will be different. Because that's the next step. Once you measure all these things, we now need to figure out, okay, where should these things be? Because metrics on their own are just numbers. If I tell you, okay, we have 4 elephants here. Okay, that's 4 elephants. What does it mean? Is that too much? Is that too little? Is that not enough? Right? We need to set objectives. So this is where picking the targets is really important. The target is essentially a measurement that expresses a value that you have. Either it's a simple one saying, oh, it needs to be this number or below this number, or it needs to be a range, it needs to be between 5 and 10. I think the number of elephants adequate for a stage is between 1 and 10. Maybe more than 10 would be fun, but then you start losing track of everything. But you need to understand, what does that value mean to you? Like, what is the difference between having 4 elephants and 10 elephants? I have no idea where I'm going with this example, by the way. But it'll make sense at some point, I swear. But it's really important. Once you start picking these targets, that you think about them. First of all, don't just base them on what you have today. right? So we're rewriting the engine of usability. We're rewriting this thing that's been there for 5 years. If I go and say, well, the old system delivered data in 500 milliseconds, so we'll just aim for 500 milliseconds. Really? You're just doing what they did before? Is that old system delivering enough data? Is there an opportunity there? What do users want? How do users engage with your system? Is there a win? So really try to understand the scenario that you're building and use all of the information you have, including the old system, as sources of information, but start that conversation. Start figuring out what that new value should be, what you want to aim for, right? Again, this sounds like a lot of great ideas, but let's bring it down concrete again. So for the pipeline, we needed to figure out a couple of these metrics, right? We needed to figure out how long it would take for us to give feedback to the person giving feedback, meta feedback. So if, instead of asking the product owners and going around the company and saying, hey, what should be the response time of the collection endpoint? Right, product owners were like, the who, the what, when? You need to talk the same language, right? We're now talking about going to various different areas of the company, people who are completely different, and having a dialogue. So we said, you know what? Let's ask them the following question. What is the, how long can it be between the user clicking on a button and receiving confirmation that his feedback was received? Simple operation, easy for everyone to understand. So we went around the whole company and we asked a bunch of people. Some of them told us it needs to be immediate. Some of them told us we sell it as real time. Guess which department that was? Right? Then we went to other people and said, well, it's 500 milliseconds because you got this huge HTML that needs to be processed into this and needs to be, guess who that was, right? Yeah, so that was the original developer. And then simply people who didn't know, didn't care, right? Now, you're not always going to get great answers. That's the life of a developer. If you're in Jeroen's workshop yesterday, you'll see that sometimes the business experts are not really that much experts, and not all the time do they all agree on the same things. But you need to be able to look at this and try to understand and force that conversation to happen. Have that dialogue with the other teams, with the other departments to understand what you're valuing. So we looked at immediate, we looked at all this information, and we looked at the technicality of it, and we tried to figure out, okay, where are we aiming? I mean, first of all, for a human mind, immediate is like around 100 milliseconds. So, we gave ourselves a little bit of a margin, and then we decided, okay, you know what, if we reply within 150 milliseconds, we allow the front end to do its thing without us getting in the way of it, right? So the front end that's finally going to give the user the reaction has a bit more space there to work with, and we're not aiming for the moon and trying to keep everything under 5 milliseconds, because that has a cost, right? Delivering each of these targets has a cost. It's not because, oh, I want to be under 150 milliseconds. Fine, why do you want it, right? Because the more you try to achieve one of these goals, the more it's going to cost you somewhere else, right? Development time, optimization, so many different things. So we decided on 150 milliseconds, which is how we got to that first metric I mentioned in the beginning. You should also not have too many SLOs. Again, we're not really good at dealing with all the information in the world, right? We need to make sure we understand the metrics that are really important to us. Ideally, all these SLOs should help you settle arguments, especially when you have discussions with product. Oh, we need 2 more days to keep working on this thing. Why? Because it's not fast enough. If you look at the SLO, when you're hitting all the SLOs, why do you want to make it faster? Oh, well, because it's, on the other hand, it's also, costing us this much. Okay, then you have a metric that you can measure, right? So these SLOs should be able to give you an answer. Do you want to invest more time here? Do we need to invest more time in there? Do we need to change this architecture? Do we need to do autonomous microservice? Do we need to care about eventual consistency, right? All of these are questions, all of these arguments that SLOs should help you figure out. And then, in a counter proposal, which is a bit, it sounds weird, but don't try to overachieve. Now this is interesting. So within the book, Google talks about an example of this, and it's the Chubby project. Anyone work at Google? No? So I was having a chat with a friend of mine who does work at Google, and actually the Chubby project is really a central part of Google. It's a system that does, I don't know what, but it's called by almost every other system within Google. So all the other systems came to rely on Chubby, which had this insane, 5 nines or 6 nines or whatever uptime metric. So everyone came to rely on Chubby always being there. And they kept throwing requests at it and all that. Now, I mean, how many of you work with AWS? All right, and how much do you trust that S3 is always going to be there? Has it ever failed? And does it fail every day? Right? So they came to rely on Chubby to the point that people were no longer thinking about fallbacks. Chubby is always there. It never came down, it's fine. Until one day, as it stands in development, it came down as a burning pile of code, right? And everything went down. And then every other system went down because they were relying on Chubby just being there. So they're like, okay, cool, now everything went down. We gave people too much to trust on, right? Oh, it's always going to be there. It's always going to be up. So what they did, and this was interesting, this is kind of a social experiment as well, they lowered their SLO to like 3 nines or whatever. And actually what they do is like month over month, if they start going past that metric, they actually bring the project down for a couple of seconds and bring it back up. Right? To be able to stay within that SLO. They don't want to get past that SLO, they want to stay within it. Because that got all the other engineers that relied on it always saying, well, you know what, Chubby may fail, we need to have a fallback. So now they no longer have cascading failures because they changed their architecture to deal with the response time, with the uptime that Chubby was actually putting out. It's kind of weird, but it's a very interesting scenario. And the other thing that's really important as you go along these lines is to adopt and evolve, right? SLOs change, your business changes, your market you're in changes, your users change. So you need to understand, do we need to keep evolving this, right? Like I said, Usabilla had a great idea at the beginning, had a great way of implementing it, got them to the market, but the market shifted. The market wanted more unification of the data. We need to also adjust with that. So it's very important for your SLOs to kind of move along with all that you're doing. And then finally, SLAs, right? SLAs is where you actually set the expectations and hopefully you meet them as well. So first of all, simple, attach consequences to your objectives. If you can't reach that SLO, what will happen? Does it have an impact on the user? Does it have an impact on the team? You know, maybe you have like a swear jar, but it's like a SLO jar. If you don't hit it, then you have to put a little money in there and then we use that in the end of the month. I don't know. But you're attaching that, right? But usually SLAs are usually between you and your client and you need to think about it. But again, this is not something that comes from development, so please, do take your legal advisor with you. The night is dark and full of loopholes. You want to understand what you're doing. Before you're committing to saying, hey, we're committing to this thing, make sure you understand what's going on. And make sure a developer is part of the conversation, but developers should not be leading this conversation. This is very much a business conversation of how do they want to have their business model tied in to the performance of the system you're developing. But if you want to have a good tip to take with you into that meeting, safety margins. If you have agreed with the user that you will achieve this SLO of 150 milliseconds, then maybe your actual SLO should be like 120, so that when it starts getting there, you have at least 5 minutes to try and figure it out before it actually has a consequence, right? So make sure you give yourself some margin there to be able to not just leak money all the time and actually have a good relationship with the clients. Cool. I've done all the theory that you needed to know about this, and I think we can now talk a little bit of in practice. So I mentioned there was Prometheus in this talk. Here it is. So why would I choose Prometheus? So Prometheus has an interesting model compared to Influx and all these other methods. And it's very scalable. So what's the difference between Prometheus? If we talk about metrics, and a couple of you are already doing this, right? Usually what you have is your application will measure whatever and will send that metric over into Influx or whatever it is, right? Which is essentially this big database of data. Now, that means that if you scale up your applications, you need to make sure your monitoring scales up with it, otherwise you'll DDoS your own monitoring and your alerts will go off, and that's probably not good. So what Prometheus does differently is, instead of sending the metrics directly to Prometheus, you store those metrics locally in a small cache. For PHP, this can be Redis, or it can be APC even, and you store that. And every so often, I don't know, once a minute, once a second, depends on how you configure it, Prometheus will come to your application and say, okay, give me the metrics. Now, again, you should be careful, because if you tell Prometheus to do that every second, it's hitting your application every second, you might DDoS yourself. So, you want to think about that, right? There's different strategies to this. Is instead of using the actual endpoint on your application to do it, you have a separate container that's only serving up the metrics. But it's a lot easier to scale than having to scale this one big solution, and it's a lot simpler to deal with. So that's what Prometheus, its claim to fame is, right? And going back to what I mentioned between telemetry and statistics, Prometheus is really good for telemetry, right? Because it's really quick at getting that information out there. It has a simplified query language that allows you to figure out the rates and follow these things in real time pretty well. So it's really good for telemetry. However, when you start talking about statistics, you're talking about long periods, right? You're talking about looking at data back a month, 2 months, or maybe more. And then Prometheus is good at it, but not great, right? You can set the retention limit on them to be really higher, but it's not the most robust thing. So you want to be able to use things like influx, and that's the advantage here is there's a plugin for Prometheus, which essentially every time the metrics comes in, it tosses it over into influx, which is really helpful. It also means that now you have this first layer of monitoring, which is Prometheus, which is easy to scale, and then it's also providing data that you can then use for the long-term stuff, and you don't have to deal directly with influx, which can also have other implications, right? You start dealing with like UDP packages instead of TCP to be able to speed it up, and you can get mixed results. So it offers 4 types of metrics. Counters, which are essentially numbers that go up. You can add labels to it, so you can say, hey, I just got a request, so increment by 1, but label it as the status was a 500, the URL was /metrics, and the HTTP code was a get, not a post. Right? So you can add these labels to these things. Histogram, same thing, but it's more tied into a time series, so it will store data in buckets, so you can look at it over time and how that goes. The difference there being then you have the gauge. The difference that it has to the counter is that it can go up and down. So if you're saying the amount of data I have in my database, it's not always a number that goes up. Sometimes you need to delete data, GDPR, and you need that number to go up and down. Then you want the gauge. And the summary is essentially the same thing as a histogram, but it does all the percentile calculations on the fly, so you can directly see that in Prometheus as opposed to having to calculate it in something like Grafana, for example. So not terribly useful unless you're doing a lot of the information directly from the source, which I don't fully recommend. If you're looking for a PHP client, this is the one that we're using at Usabilla. It's not the greatest library in the world, but it really does the job that it needs to do. It could use a couple of interfaces in my opinion, but it's a good library, it's solid, it delivers. I hear one of the organizers actually working on a new library, so that's interesting to keep an eye on. And essentially the dynamic you're looking at there is you're going to have your code. Your code will be using the library to store metrics locally in APC, for example. Then you're going to have to provide an endpoint. /metrics is the market standard usually. And that endpoint will essentially render the current state of your database in a text format that Prometheus will then come in, read, and federate it somewhere else. You don't have to worry about anything else. You don't need to clean up the database. You don't need to remove it every time Prometheus comes. You just need to store the stuff, and Prometheus will figure out on their end what happened with the data. So that takes a lot of the stress off of you. Show you a little bit of code, right? So this is an example of how you'd be able to use it. Use the library. It's a lot of code. Let that sink in. Cool. So I'll go over step by step so we can make sense of this. First of all, you have an adapter. There we go, an adapter. Well, essentially the adapter, this is where you're going to store data, right? Redis, APC, APCU, whatever you want. Then you can create the actual metric. So in this case, we're creating a histogram, and as you can see here, the parameters that I'm sending in is first a namespace, this is the name of your application generally, a metric name, so this is what are you measuring. The convention here for histogram style counters, or for histograms, is you want the very last part of it to be the unit of what you're measuring, so in this case milliseconds. So if you're measuring seconds or whatever, make sure you put that because it helps people trying to read the metrics on the other end, right? After that, you have the help text, which explains a bit more detail what that metric actually means. Then you have the labels. So when I mentioned, yeah, you can mark this as having this status or that HTTP code or whatever, these are the things that you will be able to collect about that thing you're measuring. And then finally, you have the buckets, right? For histograms, it stores data in buckets. What does that mean? It means that instead of storing, oh, I had one request with 12, one with 13, and one with 14, they all go into the bucket of things that were less than 15 and less than 1, right? It's actually the other way around. It goes, was it higher than 10? Yes, then put it there. Was it higher than and it keeps going all the way. So if you drop stuff in the first bucket, it'll end up in the other buckets and so forth, right? So it's less than or equals, actually the other way around. Which just makes graphing easier on the other end. So you don't need to really care too much, but it's important when choosing the bucket sizes to understand what each of these buckets mean to your application. So when you're saying, oh, okay, my response time was 170 milliseconds, what does it mean? What are the windows there that you want? So if you have an SLO of 150, then maybe you want to have a more fine, not too much fine grain inside. Like, you know, so everything that was below 100, everything that was below 150, that's okay, I can have those. But then, for example, if it's 150, 160, that's important. But if it's already past 200, I don't care if it's 200, 250, 300, 400, I've already failed miserably, right? So you want to care about those buckets so that it means something. It's like, this is okay, this is on par, this is not good, and this whole thing is horrible, right? You want to make sure you have buckets that resemble that. And then you can finally observe your metric, and that's as simple as calling the observe, passing in the value, in this case the milliseconds that you measured, and the labels, right? So here's where we say here, it was 200 with this URL. Cool. You can do the same thing with counters. Again, the call is very similar. The difference is counters don't have buckets because it's an ongoing number that's incrementing. And you want to use the convention of the total at the end. In terms of naming conventions, Prometheus has a couple of these in their documentation. You want to explain like, oh, is this the total of feedback items you have? Is this the feedback items on a specific day or whatever? You want to make sure that that's part of the metric name. And then in terms of using it, you call it increment with just, it'll increment by 1 or increment by a specific number if you want to do batches of incrementation. Right? I mean, that's pretty straightforward, easy to use, not much there. On the other hand, we have the metric endpoint that you want to push out that data from Prometheus. So you will see something like this. We'll go into parts. First of all, you need the adapter. Then what you do with the adapter is essentially you get a text renderer. Again, the format that Prometheus outputs is text, human readable text actually. So you can just do that. It will just push that data out and Prometheus will get it. And what that looks like is something like this. You can see that the metrics that we created here, so we have my app count total. You can see there the labels, so it has always hit the 200 slash URL path, and it has been done 6 times, right? Whereas down here, we can see that the milliseconds there were past 50, so it incremented all of those different buckets, right? So it was above 50, so 50, 100, and infinite. Cool. So now demos always fail, so I decided to do a demo. Because life was just not you know, interesting enough. So let's see if this works. So if you go to that URL there on GitHub, it's a simple repository, but it has the Docker configuration for a PHP container and a Prometheus container. If you spin that up, then you actually have an application that you can play around with. You can do a couple of these metrics, see how they behave, and see how Prometheus does that. Prometheus ships by default with a graphing interface that allows you to look at your metrics and try to make sense of them. So that's what I'm going to show you now. But if you go to this repo, there's instructions on how to run it, and what you can play around with is what I use internally to train all of our new developers working on Prometheus. For in some cases less. So, all right, so this means, okay, this is what Prometheus will be reading, this is what Prometheus will be parsing and tossing it into. And then we can go into Prometheus and we can have some fun with that data. If the, all right, I'm not sure this was meant to run at this high scale. But here, I can have my metric. So my app count total is actually just my metric here. All right, if I ask it just for that information, and I say, okay, well, let's execute this, it'll show me a graph saying, yeah, okay, these are all your different metrics. Now the thing is, it's aggregating by all the labels we had. So it's saying here, look, well, you had these many hits on that URL based on this instance, so your container, your job running in there, the status, and the URL, right? So here you can actually see that these are all the possible combinations that this application is providing. Now this information is kind of too much, but you usually want to know the whole aggregate of it, right? So I can say, I want to sum up all of these values regardless of which of these labels are there, and just give me one count. So if we look here at the graph, we now have a combination of all those metrics, and we can see it always goes up because that's what a counter does. And this essentially, you know, it's like Google Analytics for your website at this point. It doesn't mean too much, but it gives you a lot of that information. Say, I don't care. I don't care about all of these successful ones. I want to know about the error ones. You can use the Cody braces here and say, well, I want everything that has a status of 500. So if I go ahead and do that, you will see that that line should change. You can see here it dropped to like 2.5K now. So it will reflect that. So there's a bunch of operations that you can do on this, including calculating like error rates and similar things. Let me see what I have. So here I'm trying to calculate the percentile. This is more one of the complex things. So I'm doing a rate of the response time for all the 200s over a minute. So it kind of simplifies that metric. Then I'm doing a sum of all those rates, and I'm trying to get the representation of it in 99% of the time, the 99th percentile, words. And then I'm grouping then by the bucket, the URL, and the status, right? So if we look down here, you'll see that you'll have the 200 and the actual URL. And for each of those URLs, we can now say, okay, well, you know, this one is performing better than that one if I get rid of the stacking here. That's not fun information. It's not terribly easy to read the data on this graph, but you can see here that we have an average of 100 milliseconds being the highest one, which is good, still hitting our SLOs, so yay. Again, I can do here a count just by the statuses, so if I want to compare how many 200s I have, which is the red line, with the 500s and 401s here, I can do that, right? I can sum them up and then group them by the status that they have. Right? This is not terribly exciting, but it gives you an idea of what you can do, and it gives you an idea to start playing around with it and figuring out how these things work and what metrics you want to start working with. So if we go back here, and I can do that. All right, cool. All right, so quick demo. Please check out the code, play around with it if you want to get more of it. But I want to talk a little bit more about the consequences of this. Because the thing is, if you can't act, or if you don't act on, you cannot act on what you can see, right? If you don't put this up somewhere, if you don't keep an eye on these metrics, they're just numbers in a closet. And that's not going to do you any good. It's like, hey, we have an SLO, we haven't measured it in 5 years, okay? So this is an example of what we have running. We use Grafana to then iterate over this data and make pretty little dashboards. This is the dashboard for the endpoint that we collect feedback on. This is semi-simulated production, not full-on production. But what we keep track of is the error rate right there on the top corner. Next to it, we have an RPM, so how many requests per minute on each of the URLs that we have. This is an API with one URL, so it kind of makes sense to track per URL. Then in the middle here, we can see the average request time, so we can see that we are way below the 100 milliseconds there. I can barely read it from here as well. Yeah, it's reading at 2.5 milliseconds. And down here, which is not really visible now, is it? So this graph actually combines the 95th percentile, the 96th percentile, and the 999th percentile, and the 999th percentile. It's a lot of nines. But again, it shows you like, okay, taking 99% of your things, how is it going? So that's usually what you want to keep an eye on. This whole dashboard is actually available on Grafana by default. You can just download this JSON, tweak the name of your metrics, and it will give you all of these cool graphs to look at. But the other thing, the one that really is one of the favorites, my favorites to keep an eye on, is actually this dashboard, which shows us how much feedback is coming in and over what channels. So if you look on top there, we have 6 little boxes. Those are 6 different products that we have. So we have the feedback button, we have the surveys, we have the feedback button and surveys on app and web, and then we have email and in-page feedback, right? And those used to be completely separate code bases, but now we can look at all these things as one, and we can actually see, here we see an average of how many feedbacks are coming in over in this corner. So this was a slow moment of 106 milliseconds. We've seen this go up of 500 and 600 per minute, which is pretty cool to see a system dealing with that load just fine. But we can easily have an idea. Like we know now that 80% of our feedback ends up coming from the web product. People on the web apparently complain a lot more than people on the mobile. Go figure. But it's really interesting information to see because it also helps business drive decisions. So if we're thinking of making a change that impacts one product, this can tell us which product we should impact. Like, hey, if we make a change for, like we were trying to reduce the amount of data we store. Like, oh, how do we save space on things like data? Well, if you do anything with the web product, that's 80% of your data going out of that cluster, so maybe that's a good place to start, right? So these ideas should help you make decisions. But if you don't take action on your metrics, they're useless. So if you're measuring them, if you put them up on the board, don't make them like, second nature. Pay attention to what's going on there, keep an eye on them, and make sure you act as soon as something is threatened. Like the very moment you see something reaching the top, you should know what to do. You should be doing something. You shouldn't just sit there and watch. Yeah, it's gonna blow. Yeah, you might want to take action before it actually blows. So keep an eye on your SLOs and may your alerts always be green. With that, thank you very much for coming. Right, so we're going to have questions coming around. I work at a feedback company, so please give me feedback. That's the hook. I really want to know, can I do this any better? Is this what you're looking for or not? Just tell me what I can do. You can either use Joined In, usual conference website, everything, or you can try this one, which I hope is working, which will lead you to an actual usability survey. So I'll actually be able to see your feedback in the actual system I work with, which is pretty cool. Questions? One in the back.
Hi, I have a question. Which one you prefer or would suggest for Docker-based services, APC or Redis?
Docker-based services. It depends on the nature of your Docker-based services. So if you're using just web containers, essentially that are just using data over the web, like PHP FPM, you can use APC. The thing is, APC has an interesting nature, right? It's attached to the actual process. So if you're trying to measure at the same time metrics from a web container and a command line container, then you're not going to get the same APC. So that data is not really going to transmit. So if you're trying to collect data, I would go for Redis in production. APC is great for development and staging and stuff like that. But in general, I would recommend Redis over APC. APC is nice and easy if you just want to get started and start measuring. But if you have any kind of time to invest into it, go into Redis because you won't have to be worried about, well, am I running within the PHP FPM process? Do I have a separate container for my Nginx stuff? How are these things actually interacting?
Okay, would it be a good approach to, let's say, fill the Redis from containers and have one service which will be connected with Prometheus?
Okay. So what we do within our systems at least, we have one Redis per bounded context. So a bounded context for us can have a couple of APIs or a couple of workers, consumers, things like that. So all of those put the data into that single Redis, and one of our APIs will have a metrics endpoint that will read from that Redis. You can try and make a bigger Redis cluster, but then you need to start thinking about, are you overwhelming your Redis cluster as well? So it's more of a feeling thing. Look at how many things you're collecting, just how much traffic you're getting, and make sure that at least your storage is scaling up with your stuff. But usually if you make, our approach at least to it is if you break it up into smaller parts, then it's easier to manage the smaller parts than trying to manage this one big cluster that's trying to do everything.
Thanks.
Cool. One important thing also that I forgot to mention, when you measure response time in PHP, that sounds great. But that's actually the response time of just PHP, right? You're ignoring the whole Nginx layer. So if you're trying to measure the response time of your request as a whole, it's actually better to measure it within Nginx than it is to measure it within PHP. And there's a bunch of like exporter plugins for Nginx, PHP FPM, Node, whatever it is you're using, that you just plug that in. It'll start outputting all of these standard metrics for measuring Node, and then you can then gather those and collect them as the metrics of your application. So, quick tip. Any other questions? Nope. Cool. Thank you very much.